All right, 1997, BC 20. What are all the values of x for which this series converges? Again, we have a multiple choice question looking for an interval of convergence. I would point out one more time that when you have this type of problem, you want to see that this is centered at x equals 2. Since it's centered at x equals 2, the interval of convergence, or the series, should converge either at the center, which is x equals 2, at a symmetric interval about the center, or for all real numbers. And so since there's no all real numbers and there's no only at the center options in the choices there, then whatever the interval of convergence actually is must contain the value x equals 2. Not only must contain it, but x equals 2 should be at the center of that. From that, we can see that negative 3 to 3, x equals 2, is not the center of either of those. All the remaining choices have negative 1 to 5, of which 2 is the center value there. So we don't have to do the ratio test here. All we need to do is test endpoints. Test endpoints. And to test the endpoints, we're simply going to plug the endpoints in and look at the either the general term or the first few terms of the series to see whether we can identify what type of series it is and whether it converges or not. So when we plug in negative 1 there, we're going to get a negative 3. So at x is equal to negative 1, we're going to end up with negative 3 to the n over n times 3 to the n. And from that we can see for any even power terms, we are going to get the 3n in the numerator will cancel with 3n in the denominator, and we will have 1 over n. But for the odd power terms, we're going to get a negative. To make a long story short, this is the alternating harmonic series. And it converges. So far we know then that the answer can't be C because the function does converge at x is equal to negative 1. Now let's try at x is equal to 3. At x is equal to 3, we get, x is equal to 5. At x is equal to 5, we have 5 minus 2, which is simply going to be 3 to the n over n times 3 to the n. The 3 to the n's cancel, and what we end up with there is the harmonic series, which diverges. And so therefore, we cannot include the endpoint x equals 5, and so the answer has to be negative 1 less than or equal to x less than 5. Okay, and we'll stop this one at that point.